Hello class, in this video I'm going to be showing you how to evaluate an indefinite integral. Let's begin. For example 2, we want to evaluate the indefinite integral. In other words, given lowercase f of n is equal to 3 times n raised to the negative half power plus 2 times n to the fourth power minus 4 times n to the 2/3 power plus 3, find a function capital F of n such that the derivative of capital F of n is equal to lowercase f of n. In this example, capital F of n is the antiderivative of lowercase f of n. You may have also noticed that I converted the cube root of n squared to a rational exponent, n to the 2/3 power. To evaluate the indefinite integral, I'm going to start by applying the sum and difference rule. That will look like this. Next, I'm going to apply the coefficient rule to the 3, the 2, and the 4. That will look like this. Now I'm going to apply the power rule to n raised to the negative 1/2 power, n to the fourth power, and n to the 2/3 power. And I'm going to apply the constant rule to the 3. That will look like this. Since we are evaluating an indefinite integral, we need to add the constant at the end. Negative 1/2 plus 1 is 1/2. 4 plus 1 is 5. And 2/3 plus 1 is 5/3. When you divide by a fraction, you multiply by the reciprocal. So we are going to have 6n to the 1/2 power plus 2/5 n to the 5th power minus 12/5 n to the 5/3 power plus 3n plus c. Now before I box this answer, I want to make sure it's correct. If capital F of n is equal to 6 times n to the 1/2 power plus 2/5 n to the 5th power minus 12/5 n to the 5/3 power plus 3n, then the derivative of capital F of n is equal to 3 times n to the negative 1/2 power plus 2n to the 4th minus 4 times n to the 2/3 power plus 3, which is equal to lowercase f of n, which is exactly what we are looking for. And we are done.